bit about multi-step synthesis. The question has been asked to go over problem number 18.26, which involves the synthesis of different molecules starting with benzene. So the idea here being, starting with benzene, could I come up with an efficient synthesis that made some compound that had some different things maybe attached like this to a benzene ring? And specifically, this is 18.26, question number 18.26 in your textbook. Yep. And so let's take a look at, I want to start with B because B involves ideas that we've already talked about, and then maybe we'll go back to A. But looking at B, B is starting with benzene. Could we synthesize the following molecule, which is 1-chloro, 3-nitro benzene? And I wouldn't expect you to name these, but that's just what the name is. And so when I think about this, there's some components that I think about. Here, for instance, in order to instill a chlorine, I will need to use Cl2 over AlCl3. And in order to instill the nitro group, I will be instilling using H2SO4 and HNO3 in order to accomplish that transformation. And so once I've established what types of reagents I would need in order to accomplish the synthesis, at some point I'll need a nitro group through these conditions. At some point I'll need a chloro group in these conditions right here. And so once I've determined that, the question then becomes order. Which direction should I order these in first? And if I were to take benzene and then add to that the nitro group, what would happen to that nitro group when we try and add the chlorine next? So if we were to go through something like this right here, this nitro group would direct the incoming chlorine to these positions right here, meta. It is a very strong deactivator, and as a result, it will direct the incoming, this electrophile to the meta positions. If I were to add the chlorine first to the benzene, and then ask questions about where would the nitro group add to that mono-substituted benzene ring, this chlorine is deactivating, but don't forget it's still weakly orthopara directing, even though it's weakly deactivating. It's one of those exceptions. But that situation here would direct the NO2 group to these positions here. In my mind, I'm asking about the relationship between these two substituents, and they appear to be meta to one another. Ortho-meta to this. So from the chloro, ortho-meta, or from the nitro, ortho-meta. And so it seems like this route would be the best route to achieve, because if I were to add the nitro group first, it would direct the incoming chlorine to the correct position. We look like we're in good shape. Synthesis starting with benzene, we would add the nitro group, and then we would add the chloro group. And it would afford our product in the end. Let's take a look at another example. Oh, there was a sub-question that the student who asked about this as well, they asked the following question. Let's pull it up on the email that is not being recorded. They asked the following question. Would you be able to... Okay, yep, here we are. Also, what are the conditions that Friedel-Crafts alkylation does not work under, and are there other restrictions like that to other reactions? And so I was out of frame for that, sorry. But the question asked, before we go into any others, so sidebar. We know that when we are trying to Friedel-Crafts alkylate, which is this reaction right here, there are two considerations that we must make when looking at Friedel-Crafts alkylation reactions. Number one is if the reaction does take place, rearrangements are possible. So in the example above, don't forget that the propyl group that we will install is actually an isopropyl group instead of the normal propyl group, or the straight chain normal. And then number two is if we have a deactivated ring and we try and conduct a Friedel-Crafts alkylation on that deactivated ring, no Friedel-Crafts alkylation on deactivated rings. This is number two. And so here, no reaction. And the question went on to ask, is there are other considerations when looking at these reactions? No. All the other electrophilic aromatic substitution reactions, and even the things that happen to the side chains of those reactions, the reductions or the brominations at the alkyl position, those all go straightforward. There's no real exceptions. It's just in this one area, the Friedel-Crafts alkylation. Taking a look at perhaps another example here. Yeah, let's take a look at G. This one's, I'll just do G because G encompasses a lot of the chemistry in some of these other examples. But if we were to start with benzene, and certainly I must tell you that I really wouldn't be comfortable asking you a question that involved more than three or four at max steps in a reaction scheme like this. This is will ultimately end up being 5 different steps, and so to generate something like that on your own is a lot to ask on an examination. And so maybe if the solution was something like this, where you had to successfully navigate the arrangement of the regioisomers on a 2-step reaction, sure, that's manageable and something you should expect to see on the examination. But as far as doing something like the problem we're about to do is concerned, no. I wouldn't expect this from you on the examination in its entirety, but perhaps I would have you fill in chunks if I were to give you portions of the synthesis, or maybe explain steps in there. Why was this step done here? But certainly not generate it all on your own. Looking at something like this, could we synthesize this molecule, and I'm also going to write this, only as a product. And so let's just take a look at some of these things that we would have to do. If we wanted to instill this group right here, we think to ourselves initially ClCH2, something like that, over AlCl3, but then we remember there's rearrangements when we go down this road, and since the attachment of atoms here, if we were to add this, we would get a tertiary addition. So I'll just write that up here. You would expect to see this added in its place. If we want to circumvent the possibility for rearrangements to occur, we have to absolutely use the acyl group in its place. And certainly looking at just this CH3 here, those conditions would work just fine. A methyl group isn't going to rearrange on us at all. Then the question becomes order. What are we going to do here? And This isn't necessarily the worst thing, because in R group, which both of these are, they're going to direct here. Both of these things, depending upon if it's a methyl group or if it's this this isopropyl group that's attached here, both of those things would be directing to the para positions and the ortho positions. But I have this word here, only. And so if we were to conduct maybe this reaction first and this reaction second, we have an issue here, because we still have to contend with the fact that we don't want any para substituted addition either. And that's something that I'm going to address when I go through this solution here. We have the choice of doing a Friedel-Crafts acylation, or we have the option of doing a Friedel-Crafts alkylation first. For all practical purposes, either one is going to work first. The solution in your solutions manual is going to go with the acylation first. I am going to go with the alkylation first, just so you have some variety in solution. But I would functionally add first, fix that, haha, CH3, Cl, AlCl3, and this should impart to us the addition of that methyl group right here. And now what I would want to do next then is logically add the Friedel-Crafts acylation reagent in the presence of AlCl3, but that would add at the para position, and I don't want to add anything in the para position. And this isn't a lesson that we talked about in class, but it's something you're probably seeing in some of your solutions, and I just wanted to go through it briefly, which is, in order to make sure that we don't make any of the para product, what we want to do is put a placeholder there that would allow us to impart chemistry on the ortho position so that that position is blocked. Then we add the stuff in orange, the Friedel-Crafts acylation, and then we take off that blocking thing at the para position to make it look like it was never there. And what I mean by that is by taking this product then and reacting that with, my reagents here are H2SO4. And that is fuming. And what that does is that ends up imparting this at the para position of this benzene ring. And then at this point in time, we can then add the Friedel-Crafts acylation and because both of these things are directing to the same position, we will see a very nice yield when we add that acylated product. And here's where the cool part comes into play. We can take this product and use H2SO4 that is dilute, and that's going to remove that sulfonyl group and place a hydrogen there instead, which makes it look like nothing was ever there. And that's the whole point, because then we can take this product, zinc, I believe, over HCl, reduce this product, and we would be left with what looks like just the ortho-substituted positions with respect to one another. Hopefully this gives you a flavor of something that's certainly within the wheelhouse of the examination, and then certainly something that could show up on an examination, but it would be very difficult for me to ask you to generate a 5-step synthesis like that. But if we were to take and say, fill in the reagents in the product that would be necessary, the reactant and product to make this, What are the reagents that you would need to do the next step? Fill in those places. Maybe that's something that would show up on an examination. Hopefully this helps you and gives you some ideas of how multi-step synthesis could show up on an examination. The last thing that I will say is look at the web of reactions on the examination. I will be testing you on almost all of the reactions, if not all the reactions, from electrophilic aromatic substitution type reactions and their side chains. Once you have the reagents that are there, when you move to these multi-step synthesis, look back for reagents in that web. For instance, if you know you need to add a chloral group there, go back to the web and see, did Dr. Shaw add a chloral group at any point in time? And he did. He used Cl2 and AlCl3, so that means when I add my chlorine group that I should use those reagents. I am deliberately putting reagents in the examination that you will use later on in the examination. And many times I'm telling you what the product of the reaction is. And so it looks like, hey, Dr. Shaw's an idiot. He forgot and he left a set of reagents that I was supposed to use in the multi-step synthesis in the web too. That's not me being an idiot. That's the spoon thing when I was washing it. This is totally different. This is me giving you material that you could then use later on in the examination, and I want to see you use it. So if you're stuck on what reagents you need, don't forget to look back at the web at the reactions that I've given you already, because you're likely going to need them in your multi-step synthesis, and I'm trying to help you out. Good luck on your preparation. Keep those questions coming.